Hi, hello, I'm Kiran Kumar from Nature of Physics and Art. Welcome to my channel. Today's topic is magnetic induction due to the long straight current carrying conductor. See, friends and my students, I'm doing clearly videos from the first year physics along with the second year physics in NEET, mains and advanced level. Please, many videos are available in the playlist. Please watch that videos and like my videos and subscribe my channel Nature of Physics and Art. Now, magnetic induction due to the long straight current carrying conductor. L is the length of the conductor, this vertically taken, and I is the current upward direction in the conductor. See. O is the center of the conductor. We wanted to find magnetic field at a point P, that is dB, due to the element is dy. So there is a small element dy. With that, magnetic induction is dB. So we are applying right hand thumb rule. Here magnetic field is out of the paper. Here magnetic field is into the paper. And magnetic induction at a point P at a distance r from the element, it is making an angle theta. See, now this is center and at a distance d from the point P, this is perpendicular distance of the conductor from O to P. This is the alpha and this angle is beta. See, so this is anti-clockwise and this is clockwise. Alpha is anti-clockwise, beta is clockwise with respect to end points of the wire at a point P. See, I gave you clearly, and this is the angle phi. According to the Biot Savart law, we wanted to find the magnetic induction at a point P due to the small element of the long straight current carrying conductor. See, for this Biot Savart law formula, dB, which is equal to mu naught by 4 pi IDL sin theta divided by r square. See, r element to the point P distance, and try to understand here the values we have to replace, that is dl is dy because of element is taken as dy. Okay, so for this integration on both sides, integral dB, which is equal to mu naught by 4 pi into I is constant is common, integral minus beta to plus alpha, because of anti-clockwise angle is positive and clockwise angle is negative with respect to point P. See, dy sin theta divided by r square. Now dy value, sin theta value, r square value we have to replace step by step. So for this, first I am writing here tan phi, which is equal to, this is opposite is y by adjacent side is here d. So for this, y is equal to d into tan phi and dy, which is equal to d into secant square phi into d phi. So we got here dy value and also theta value. And this is from the triangle O, this is taken as P and this is taken as Q, O P Q. So 90 degrees, this is right angle at O, plus this angle is theta, and at point P is phi, which is equal to 180 degrees. Now here theta, which is equal to, this is 90 minus phi. So sin 90 minus phi, which is equal to cos phi. 90 minus phi, which is equal to cos phi. This is also completed. Next for R. So I am taking, this is cos phi, which is equal to adjacent side by hypotenuse. Adjacent side is D by hypotenuse is R. So R, which is equal to D divided by cos phi, that is D into secant phi. Three values we got. This is the first value, this is the second value, this is the third value. According to the formula, we have to replace these values. See now, for this magnetic induction, integral dB is B, which is equal to mu naught I divided by 4 pi integral minus beta 2 plus alpha. Dy value is d secant square phi into d phi, and sin theta value is that is here sin 90 minus phi, that is cos phi divided by r square. R square value is d square secant square phi. We can write here sin theta, which is equal to cos phi. Proof we did here. Okay, so this is d square get cancelled, secant square phi cancel, and next remaining value is b, which is equal to mu naught I divided by 4 pi integral beta minus beta 2 plus alpha. The remaining value is cos phi into d phi, and here d value is common, that is writing 1 by d in the denominator, 1 by d. Just a second. Here I took first Biot Savart law, in which mu naught I by 4 pi is constant, and remaining value di sin theta by dy into sin theta divided by r square. So dy value is d secant square phi into d phi, and sin theta value is cos phi, and here r value is d secant phi. The proof already we did. Now the values replaced here, we got the resultant equation mu naught I divided by 4 pi d, so minus beta to alpha cos phi d phi. Just a second. And continuation here, b, which is equal to mu naught I divided by 4 pi d into integral cos alpha is, integral cos phi is sin phi. So that minus beta, and here upper limit is alpha. So b, which is equal to mu naught I divided by 4 pi d sin alpha upper limit minus sin beta, minus of minus plus, minus beta, minus of minus plus. So we got here b, which is equal mu naught I by 4 pi d sin alpha plus sin beta for the magnetic induction due to the long straight current carrying conductors. And next, if the give angle is alpha 1 at the first edge and here beta 1 at the second edge, beta 1. So this is beta, this is alpha, this is alpha 1, this is beta 1. So alpha 1 and beta 1 is making an angle at the end points of the conductor with respect to point P. See now, for this clearly we can understand here alpha 1 plus 90 degrees plus alpha, which is equal to 180 degrees. So alpha is equal 90 minus alpha 1, and beta, which is equal to 90 minus beta 1 is replacing in this equation. We will get B, magnetic induction at a point P. So mu naught I divided by 2 pi d, that is sine alpha value is 90 minus alpha 1 plus sine 90 minus beta 1. So the resultant equation is B, which is equal to mu naught I divided by, here 4 pi d, that is cos alpha 1 plus cos beta 1. So this is the first equation and this is the second equation for the current carrying conductor producing the magnetic field at a point P. Next video, applications of the long straight current carrying conductor. Now, continuation, magnetic induction, application of the long straight current carrying conductor. Magnetic induction is inversely proportional to the distance. If the distance is increases, magnetic induction is decreases. That's why here the graph BD graph, that is B on the y axis magnetic induction and D is on the x axis. So the curve is hyperbola because of B is inversely proportional to the D. And next, magnetic induction along the length of the conductor. So there is two possibilities. First one is here dy is parallel to the r bar. That's why theta is equal to 0 and sine 0 is equal to 0. Now continuation here using this formula. So integral dB, which is equal to B. So d, which is equal to integral mu naught by 4 pi I dl sine 0. 0 into anything is 0. That's why what will happen. So magnetic induction is equal to 0. If theta is equal to 180 degrees, then sine 180 also 0. So then the resultant equation, magnetic induction again is equal to 0. Along the length of the conductor, magnetic induction is 0. See, upward direction 0 angle, downward direction 180 degrees, sine unit also 0. Just a second. Thank you. Please like this video and subscribe my channel.